All right, students, I want to show you how to do some basic statistics with free software that's available out there. And so what we're going to start out with is, in this video, we're going to go over t-tests. So the two software programs that I like Excel for data organization, and then I like JASP because it's a free statistical software package out there that's actually pretty powerful. It does a lot of stuff that often SPSS would do, or other more advanced statistical programs, but it's in a very user-friendly manner. And this is the thing, almost all of it can be entered or uploaded into JASP in a way that's visually appealing and makes sense in Excel. So what I'm going to do here is, let me go ahead and open up JASP. Take just a second. And I'm going to share my screen with you so that you can see what I'm doing at the same time. So JASP, like I said, is free. You download it, and when you open it up, it's going to look something like this. Okay. And to open up a file, what you do is you click open, and then you go to computer. It's just like you'd open up a file on your computer, and you find what you want to open up. So what I'm going to do is, before I go there, I'm going to show you what the Excel file would look like. So I have here my t-test file. So I'm going to open it up. And what I have here is treatment, no treatment. And this would be participants. This is a participant, another participant, another participant. And this is treatment, the treatment they received, and then the no treatment. So let's use the example of 100-meter dash time with and without some special supplement that's supposed to improve 100-meter dash time. So if I took my class and I had all of you do 100-meter dashes normal, that would be considered the no treatment. And then I had you come back at a different time and take the supplement and then perform a 100-meter dash time, that would be considered the treatment. And what we're looking for in a t-test is, we have two columns of data, and we want to know whether this column is significantly different from this column. In other words, did the treatment cause a difference in the individuals? Okay. Now, when you're doing Excel and you click save, it's going to save it in an Excel file. JASP likes Excel files to be saved as CSV. So click File, Save As, and when you go to the Save As, make sure you choose the CSV that's comma delimited right here. Okay. And I've already saved it, so we're just fine. So I'm going to go to my JASP file. I'm going to browse, and I'm going to open up my t-test. And notice it looks the exact same as how I uploaded it in the CSV. That's what I like about JASP, is you don't have to, for most part, you don't have to rearrange things to have it make sense. Okay. And then up here, you can choose what type of test you want to do. Well, we know, since there's two columns and we're comparing to see whether there's a difference between the two groups, which is technically it's one group that did two treatments. Well, what type of test? Well, we're going to do just a standard t-test where we don't mess with this right here. And is it an independent sample, a paired sample, or a one sample? Well, in this situation, we said that the participants repeated the protocol. So that would be the same as a paired sample. Okay, so we're going to click paired sample t-test. And what were the variables? Well, one variable was treatment. The other one was the no treatment. So these are really the columns in CSV. Okay, and that's it. Bam. And the t-test, a standard t-test, is also called a student's t-test. And here it spits out our results. So the p-value is 0.011. And if it's less than 0.05, we would say that that's significant. So in other words, the treatment caused a significant difference. So in this situation, the treatment caused a significant what? Improvement or reduction? Well, we can come down here and we can go to descriptives. And if the mean of the treatment was 16.2 seconds and the mean of the no treatment was 19.2 seconds, that means that the treatment caused a reduction in time. Okay, if this had been flip-flopped, then we'd say that the treatment caused an increase in time, and the difference was significant. So see how simple that is? And the cool thing about JASP compared to maybe Excel is instead of having to search on doing plots and stuff, you actually can just click on it. I wanted to have a descriptive plot. Boom, there it is, your average plus or minus it's going to have standard deviations in there. You can click all sorts of things and you can kind of play around with it. Now, again, what we were saying is that the one group, the treatment was significantly different from the no treatment. Okay, so in other words, measure 1 is not the same as measure 2. Remember how we've mentioned one-tailed or two-tailed tests? We always do two-tailed. This would be an example of two-tailed. These are examples of one-tailed. If we only wanted to know if the treatment was greater than the other one, we'd choose this. We never do that in our biostatistics. We always choose a two-tailed test. So that's how you do a repeated measure or a paired t-test using JASP. Well, what if, let's just go back. This is the one flaw with JASP. I don't know why the creators of this did it this way, because I can organize my data in Excel in a visually pleasing manner like this. I can upload it and I can do all the other statistics except for a independent t-test. I have no idea why they did this, but if I were to start over, and let's just pretend that this was actually two groups, okay? So in Excel, I would actually look at it this way. I would just know that, because I was the one who designed the study, that I actually had one group of people come in and they received the supplement, and I had a completely different group of people come in and not receive the supplement, okay? So in other words, the groups were not the same people. That would be an example of an independent t-test. Well, you go to t-test and you go independent samples, and guess what? It doesn't like it. It's not going to run a p-value. The reason why is it wants you to go back to Excel and create this column, one of the columns that says like this. Take just a second here. Instead of organizing it like this, it wants you to say like group. Whoops. And then you would have treatment, or no treatment. And then this would be the time. And you would have to match those up. Then you upload it. And what happens is the grouping variable would be the group and the variable would be time. If you want to do it like that, you can, or this is when I just do it in Excel because I can just do equals to t-test. I have my first array. I have my second array. I have it as a two-tailed. And then just like this, I have it as a two sample. Boom. Okay, so 2. And it gives me my p-value right there. So t-tests are really simple to do in Excel, either repeated measure or a independent t-test. We don't do independent t-tests that often in exercise physiology, because often we want, if it's a human subject, we want them to repeat the test so that we eliminate any variability between individuals, okay, in different groups. The big advantage with t-tests is that if I wanted to try to do plots and stuff in here, I'm going to have to go insert and find a formula, select the data, and it becomes kind of problematic. But anyway, that's how you do t-tests in Excel and in JASP. And if it's a repeated measures t-test or a paired t-test, I almost always just do it in JASP, because then I can come back. In this situation, I'm going to actually change it, pretend it's a paired t-test, okay? Boom. Boom, it's done. I can do confidence intervals, descriptives, all of this stuff that I would have to actually go in Excel and type equals to average, equals to standard deviation and stuff like that. So hopefully that's helpful in understanding how to use Excel and how to use JASP to do t-tests.